Hello 7th graders, good afternoon. Today we will discuss our second worksheet of pressure. You've tried to do it last week. Now I will give you all of the answer keys in complete discussion. Unfortunately, we cannot do this discussion in face-to-face meeting. Therefore, I made you this video so that you can get all of the correct answers, since this worksheet will become one of the material for your final exam. Let's begin our discussion from number 1. The diagram shows a simple mercury barometer. If atmospheric pressure increases, state whether level X and level Y goes up, goes down, or stays the same. The atmospheric pressure is pushing this level of mercury and also this one downwards. So when the atmospheric pressure increases, of course, level Y will become lower than the initial position. So we can say that level Y goes down. The mercury, which is pushed down at level Y, goes into this part of the tube, which will make level X higher. So we can say that level X goes up. Those are the answers for the question number 1. Level X goes up, level Y goes down. Four flower vases have circular bases. They are filled with water so that they all have the same weight. Which vase exerts the greatest pressure on its base? Put a tick on the correct box. Remember, pressure equals to force over area. From the problem we know that all vases have the same weight. So all the force pressing down the vase on its base. Here are the forces. This is F. This one also F. F and F. All 4 F's have the same values. Therefore, to find the greatest pressure, we have to compare the area of the base of each vases here. From the drawing or from the figure here, we can see that this vase has the smallest surface area on the base. You cannot do any measurement, but I think from your eyesight, you can see that this one has the smallest surface area on the base. Okay? So the one that has the smallest surface area on the base will have the greatest pressure based on this formula. The smaller the area, the greater the pressure. So let's put tick on this box because this vase has the greatest pressure. Let's move on to question number 3. The diagrams show 2 divers swimming in the sea and 2 divers swimming in fresh water. Seawater is more dense than fresh water. On which diver is there the greatest pressure? Give reason to your answer. From the problem, we know that the density of the fresh water is greater than the density of the seawater is greater than the density of fresh water. Let's write down density of seawater is greater than the density of fresh water. How do we know this? It is said here, seawater is more dense than fresh water. That means the density of seawater is greater than fresh water. Now, pressure equals to density of the liquid times acceleration of free fall or acceleration due to gravity times the depth of the object. So we know that pressure is proportional to the density and also the depth of the object. Therefore, we will choose seawater instead of fresh water to find which diver has the greatest pressure. Why? Because the density of fresh water is less than the density of seawater. Yeah? Now, after we choose the seawater instead of fresh water, let's compare the depth of the two divers here. Diver A is on 2 meter. Diver B is on 6 meter depth. So we know that diver B has deeper depth than diver A. Based on this formula, the greater the depth, the greater the pressure. So we know that diver B experiences greater pressure compared to diver A. So the answer to this question is diver B experiences the greatest pressure. Pressure inside a liquid is proportional to the depth of the object, also to the density of the liquid. The greater the density and the deeper the object, the greater the pressure. Let's continue our discussion to number 4. A garden pot containing soil weighs a total of 360 Newton. The pot rests on 3 equally spaced blocks so that surplus water can drain out of the holes in the base of the pot. The soil is uniformly distributed in the pot. The pot is shown in figure 4.1. 4a. What is the force exerted by each block on the pot? To answer this question, let's go back to figure 4.1. On figure 4.1, we can see that the pot is supported by 1, 2, and 3 space blocks. These blocks behaves as a support. That means the weight of the pot will be supported by these 3 blocks. The total weight of the pot and the soil inside it is 360 Newton. So, the force exerted by each block on the pot is equal to 360 divided by 3 because there are 3 blocks supporting the pot. So the force on each block is 120 Newton. Question 4b. State the direction of these forces. Let's go back to figure 4.1. The three blocks 1, 2, and 3 behave as a support system for the pot and also the soil inside it. So, the three blocks must withstand all the weight from the pot and the soil. The weight of the pot and the soil inside it goes downwards. This is the weight. The support from the three blocks must make the pot balance. So, the direction of the forces must oppose the direction of the weight. Since the direction of the weight is downwards, we can conclude that the direction of the forces on the support go upwards. So on each support, on each block, the force go upwards. Now let's answer question 4b. State the direction of these forces. The answer is upwards. Question 4c. The gardener finds that the blocks sink into the ground, but he must have the pot up on the blocks to allow the drainage. What can he do to reduce the sinking of the pot? On figure 4.1, we can see that the contact area between the block and the ground is quite small. Even though we have 3 blocks here, the total contact area from the 3 blocks is still quite small. This will cause the pressure from the pot to the ground become quite big, and that's what makes the pot and the block sink into the ground. To prevent the sinking, we have reduced the pressure caused by the pot to the ground. We cannot change the weight of the pot, but we can change the contact area from the pot to the ground. So, the gardener must make the contact area from the pot to the ground becomes larger. Then, what can he do? The gardener must put a whiteboard under the blocks to reduce the pressure from the block to the ground. This will prevent the sinking of the pot. Let's continue our discussion to number 5. Figure 5.1 shows a sealed glass syringe that contains air and many very tiny suspended dust particles. The air in the syringe is at a pressure of 2.0 times 10 to the power of 5 Pascal. The piston is slowly moved into the syringe, keeping the temperature constant until the volume of the air is reduced from 80 cm³ to 25 cm³. Calculate the final pressure of the air. To do this calculation, we have to use this equation. P1 times V1 equal to P2 times V2. P1 is the pressure for the first condition. V1 is the volume for the first condition. P2 is the pressure on the second condition, and V2 is the volume on the second condition. Which one is P1? Which one is V1? Which one is P2 and which one is V2 in the problem? This is the first condition. The air in the syringe is at a pressure of 2 times 10 to the power of 5 Pascal. So this is the initial condition. Because this is the pressure for the initial condition, then this is P1. The volume of the air is reduced from 80 to 25. So this is the initial volume, and this is the final volume. The initial volume, 80 centimeter cube, is V1, while the final volume, 25 centimeter cube, is V2. And the one that we have to calculate is the final pressure, that is P2. Now let's put in all the values into the equation. We get 2 times 10 to the power of 5, that is P1, times 80. 80 is V1, equal to P2 times V2 is 25. Now for this equation, you don't have to change or convert the unit of the volume from centimeter cube into meter cube, just for this equation, okay? As long as V1 and V2 have the same unit. So if 80 and 25 have the same unit, you don't have to change the unit into anything. Just use the unit as it is. Okay? 2 times 80 equal to 160 times 10 to the power of 5 equal to P2 times 25. So P2 is 160 divided by 25. We get P2 equals to 6.4 times 10 to the power of 5 Pascal. That's the answer to the question. Pressure equals to 6.4 times 10 to the power of 5 Pascal. Let's continue our discussion to number 6. A manometer is being used to measure the pressure of the gas inside a tank. A, B, C, and D show the manometer at different times. At which time is the gas pressure inside the tank greatest? Give reason to your answer. The answer is the gas pressure inside the tank will be the greatest at time D. The reason? The gas pressure inside the tank pushes the mercury in the left tube downwards. Therefore, the greater the gas pressure, the lower the mercury level. Guys, I want to show you how to compare the pressure for each drawing in this problem. In drawing A, the mercury level in the right side is lower than the left side. This shows us that the pressure inside the open tube is greater than the pressure from the gas inside the tank. The pressure in the open tube comes from the atmospheric pressure. Drawing B, also the same as drawing A. The atmospheric pressure in the open tube is still greater than the pressure from the gas inside the tank. But in drawing B, the gas pressure now becomes a little bit greater than drawing A. We can see that from the level of the mercury inside the left tube here is a little bit lower than the mercury level in drawing A. In drawing C, the pressure from the atmospheric pressure in the open tube is equal to the pressure from the gas inside the tank. Drawing C shows us that the level of the mercury inside both tubes is equal. This shows us that the pressure for both sides of the tube also equal. Drawing D shows us that now the gas pressure inside the tank is greater than the atmospheric pressure in the open tube. We can see here that the mercury level in the left tube is lower than the mercury level in the right tube. From that, we know that the gas pressure inside the tank is greater than the atmospheric pressure. So the lower the mercury level in the left tube shows us that the gas pressure inside the tank becomes greater. So just choose the drawing with the lowest level of mercury in the left tube. That shows you that the gas pressure inside the tank is the greatest. But if the question is changed into which time is the gas pressure inside the tank lowest, then you have to choose the highest mercury level in the left tube, which is drawing A. Okay? Remember, the lower the gas pressure inside the tank, the higher the mercury level in the left tube. But the greater the gas pressure inside the tank, the lower the mercury level in the left tube. So read the question carefully, yeah? Let's continue our discussion to number 7. 7a. In figure 7.1, the sealed drum containing gas has a mercury manometer connected to it in order to indicate the gas pressure. For convenience, gas pressure is often expressed in millimeter of mercury. The gas pressure is 781 millimeter of mercury and air pressure is 760 millimeter of mercury. 7ai. State the difference in height between levels A and B on the manometer. Let's take a look at figure 7.1. The difference of height between A and B represents the difference of the pressure between gas and air. Level A is lower than level B because the gas pressure is higher or greater than the air pressure. So, the difference height between A and B can be calculated as 781 millimeter minus 760 millimeter. Once again, the difference of height between A and B represents the difference of pressure between the gas and the air. This equal to 21 millimeter. This is the answer for question 7AI. The difference in height between levels A and B on the manometer equal to 21 millimeter. 7A. The temperature of the gas rises. State what happens to number 1, the gas pressure. When the temperature of the gas rises, the gas pressure increases. That's the answer for number 1. The gas pressure increases. To answer question number 2 and 3, we have to go back to figure 7.1. In figure 7.1 here, we can see that when the gas pressure increases, it will push the mercury level on A downwards. And it will also push the mercury level on B upwards. This will make the mercury level on A lower while on B higher. So we can now answer question 7A number 2 and 3. Number 2, the level A lower, level B will become higher. Question 7B. The air in part A is also pressing on a large window pane in the wall of the room where the drum is situated. 7BI. State how the air pressure on the window pane compares with the air pressure on the mercury surface at B in figure 7.1. Let's take a look figure 7.1. The mercury surface at B only pressed down by the air pressure. There is no other pressure on the mercury surface at B. Since both drum and the window pane are situated in the same room, they both will experience the same amount of air pressure. When two objects or more are placed or situated inside the same room, all the objects will experience the same amount of air pressure. So now we can answer question 7BI. The air pressure on the window pane will be the same as the air pressure on the mercury surface at B, of course, yeah? Because only the mercury surface at B pressed down by the air pressure, while at A, the mercury level is pressed down by the gas pressure inside the drum. Question 7BII. State how the force exerted by the air on the window pane compares with the force exerted by the air on the mercury surface at B. Once again, let's take a look at figure 7.1. The surface area of the mercury level at B is very small, while the window pane has a very large surface area. Mercury level or the mercury surface at B experiences the same amount of air pressure as the window pane. Now let's go back to the question. State how the force exerted. Remember this formula. Pressure equals to force over area. We can modify the equation into force equals to pressure times area. Both window pane and mercury surface at B experience the same amount of air pressure. We know that from the previous question. Since mercury surface at B has less surface area compared to window pane, so we know that the force exerted by the air on the window pane will be greater than the force exerted by the air on the mercury surface. Because they both experience the same amount of pressure, but window pane has greater surface area compared to the mercury surface at B. Let's continue our discussion to number 8. Two boys, X and Y, each have the same total weight and are standing on soft ground. Which boy is more likely to sink into the soft ground and why? The boy which is more likely to sink into the soft ground is the one who has the greatest pressure. Pressure equals to force over area. In this case, the force is the weight exerted by each boy. Now from the problem we know that they have the same total weight. So the boys exert the same amount of force or weight to the soft ground. Since the forces are equal for both boys, we can compare their pressure by comparing the contact area between each boy to the soft ground. This boy, boy X, has less contact area compared to boy Y. We can see in the figure that boy Y is wearing a special snowshoes. Snowshoes, of course, have larger contact area compared to just regular shoes. The less the contact area between the boy and the soft ground produces greater pressure. Because we know here from the equation that pressure is inversely proportional to the contact area. So, boy X is more likely to sink because he is the one who has less contact area and therefore produces greatest pressure. Now let's answer this question. Boy X is more likely to sink into the soft ground because his feet have less contact area with the soft ground than boy Y. The lesser the contact area, the greater the pressure and the easier for the boy to sink. Let's continue to number 9. Liquid X has a density of 10,010 kg per meter cube. Liquid Y has a density of 950 kg per meter cube. The liquids are poured into tubes as shown. Which tube has the greatest pressure on its base? Give reason to your answer. Let's compare the pressure for the 4 tubes. Pressure in liquid equals to the density of the liquid times the acceleration due to gravity or acceleration of free fall times the depth of the liquid. We know from the problem that the density of liquid X is greater than the density of liquid Y. So, to know which one produces the greatest pressure, we have to choose liquid X instead of liquid Y. So that left us with only two tubes here, A and C. The four of them experience the same amount of acceleration due to gravity, so we can skip that part. Now let's compare the depth of the liquid. Between A and C, tube A has greater depth than tube C. So, we have to choose tube A to produce the greatest pressure on its base. Because, once again, the depth of tube A, this is the depth, is greater than the depth of liquid X inside tube C. Let's answer the question. Tube A has the greatest pressure on its base. Pressure of the liquid proportional to the density and the depth of the liquid. The greater the density and the deeper the depth of the liquid, the greater the pressure. Okay, now let's continue our discussion to number 10. Figure 10.1 shows a pond that is kept at a constant depth by a pressure-operated valve in the base. (10A) The pond is kept at a depth of 3 meters. The density of water is 1000 kg per meter cube. Calculate the water pressure on the valve. To calculate the water pressure on the valve, we have to use the equation to calculate the pressure of the liquid. The equation to calculate the pressure of the liquid is this one. Pressure equals to the density of the liquid times acceleration due to gravity or acceleration of free fall times the depth of the liquid. The acceleration of free fall is 10 meters per second squared. Even though it is not stated in the problem, you have to memorize the value of the acceleration of free fall. Once again, the acceleration of free fall is 10 meters per second squared. Please memorize the value. So now we can calculate the pressure. The density of water is 1000. The acceleration of free fall is 10. The depth of the pond is 3 meters. Multiply all of them. We get pressure equals to 30,000 Pascal. Let's fill in this into the provided space. Pressure equals to 30,000 Pascal. Question number 10B. The force required to open the valve is 60 Newton. The valve will open when the water depth reaches 3 meters. Calculate the area of the valve. There is one other equation to calculate pressure. Pressure equals to force over area. Since in this question, we are asked to calculate the area of the valve, we can modify this equation into area equals to force over pressure. So, to modify this equation, just exchange the position of P and A. Yeah, the correct equation for A is force over pressure, not pressure over force. In the previous quiz, a lot of you made the mistake here. You calculate area as pressure over force. Now, this is incorrect. The correct one is this one. Yeah? Exchange the position of area and pressure here. Okay? So, now we can calculate the area of the valve by using this equation. Area equals to force over pressure. The force is stated in the problem, 60 Newton. The pressure, we get this from the previous calculation. This one, pressure equals to 30,000 Pascal. Because the depth of the pond in this question is 3 meter, and in question B also 3 meter. So we can use the same amount of pressure as the previous question. 60 divided by 30,000 is equal to 0.002 meter squared. If you want to write down this value in centimeter squared, just multiply the value here by 10,000. Multiply the 0.002 by 10,000. Then you will get this value as the area of the valve in centimeter squared unit. Yeah? Can you answer this question in meter squared? Yes, you can. Okay, so you can choose which unit you want to use. Is it meter squared or centimeter squared? They both are correct, as long as you write down the correct value, of course. So the area of the valve is 20 centimeter squared. Or you can also write down 0.002 meter squared. We move on to number 11. Figure 11.1 shows a cylinder at atmospheric pressure and is then slowly compressed. The diameter of the piston is 5 cm. 11a. Calculate the area of the piston. Use pi equals to 3.14. From the drawing, the piston looks like a rectangle. Actually, the piston is a cylinder. Because the piston is a cylinder, then this side of the piston actually has a circular shape. So to calculate the area of the piston, we actually have to calculate the area of a circle. The formula to calculate the area of a circle is area equals to pi times r squared. R is the radius of the piston. In the problem, the diameter of the piston is 5 cm. Recall your memory. Diameter equals to 2 times radius. Or we can say that radius is half of the diameter. So radius equals to half times 5, which is 2.5 centimeter. This is the value that you have to put into this equation, not the 5 centimeter. Okay? Now let's calculate the area of the piston. area equals to, use pi as 3.14. This is the one, yeah, 3.14 times 2.5 squared. Don't forget the square, okay? The 2.5 comes from this. Radius is half of the diameter. Use your calculator to do this multiplication. You will get area equals to 19.625 centimeter squared. Write the answer on the provided space. Area equals to 19.625 centimeter squared. Let's continue our discussion to number 11b. A 785 Newton force is given to push the piston in. Calculate the pressure caused by the piston to the gas. We will use the equation pressure equals to force over area. The force is 785 Newton. From the problem here, area is the one that we calculated before, 19.625 centimeter squared. Guys, to calculate pressure, the area must be in meter squared. Don't use centimeter squared, okay? So, to change the area from centimeter squared into meter squared, you have to divide the value in centimeter squared by 10,000. This is a fractional division. So you have to flip the fraction here. The equation will become 785 multiplied with 10,000 over 19.625. This comes from this fraction flipped. The upper becomes the bottom becomes the upper. Yeah? Use your calculator, then you will get pressure equals to 400,000 Pascal. You have to remember this part. Please memorize this. That pressure, to calculate pressure, you have to make the area into meter squared. Okay? Once again, to calculate pressure, the area must be in meter squared. So if you have any other unit than meter squared, you have to change the unit first into meter squared. In this problem, since the area is in centimeter squared, to change it into meter squared, divide the area by 10,000. The division make the equation into this form. Yeah? Put the answer into the provided space. Pressure equals to 400,000 Pascal. Now, we are going to discuss the last number in this worksheet, which is number 12. A student places his thumb firmly on the outlet of a bicycle pump to stop the air coming out. State whether the pressure and the volume of the trapped air decrease, increase, or stays the same as the pump handle is pushed in. To answer this question, I think you can use your daily experience. Yeah? When you push something, you will reduce the volume. of the object. So, we will answer volume part first. When the pump handle is pushed in, the volume decreases. When the volume decreases, definitely the pressure increases. Okay? Please remember, pressure and volume are inversely proportional to each other. Yeah? So when the volume decreases, the pressure increases. And when the volume increases, the pressure decreases. This is the end of our worksheet discussion for today. All of the materials that I posted today are the materials for your final exam. I will reopen the expiration time after today's PJJ over. Okay? So you can re-study, you can re-watch, you can reread everything in today's material for your final exam. Please study well, please prepare well for your final exam. I hope all of you can pass the final exam without any final remedial. And I also hope that all of you can pass to the 8th grade without any difficulties. Okay guys, so good luck for your final. Maybe we will meet again in the month of July. Let's just hope so. Let's hope that our school can be reopened in July after this pandemic in our country considered to be over. Bye guys. Good luck for your final.